Hi, second year students, homogeneous equation, exercise 4.3, question number 7 to 11. The remaining questions are based on initial condition to determine C. Without wasting time, let's jot down how to solve this differential equation. It is a differential equation having no constant term. It's variable, 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 overall variable, variable. If there is a constant, it would have three. We are at a fork whether the system is parallel or not parallel. If they are parallel, the assumption based on based to convert this reduce this to a reducible homogeneous equation is somewhat different. If they are not parallel, if they have a solution, unique solution, then their assumption is based on their roots. It's not our case here. Somebody asked, I explained. Homogeneous equation, just utilize the assumption y is equal to vx. Instead of dy upon dx, insert v plus x dv upon dx. Separate the variables. It is separable differential equation. Towards dx, x term suits. Towards dv, v term suits. Then replace the value of v, that is y over x, and we are done. Question number 7. dy over dx is y square plus y times x over x square. What's our assumption? Y is equal to vx. Differentiate with respect to x, product rule. V, same differentiation of x is 1x, differentiation of v is dv over dx. Plug in both these assumptions here. We have some sort of, we arrived at v plus x dv over dx instead of dy over dx. Y means v square x square. Y means v times x overall x square. Taking x square common from the numerator, we have v square plus v left in the bracket x square, cancelled out. We have v plus x dv over dx is equal to v square plus v. Shift v on the right hand side, x dv over dx, we have v square plus v minus v, cancelled out. We have x times dv over dx, v square. Now we need neither differential dv and dx in denominator. Dv, it is already in numerator. Shift dx, it will become x dv is equal to v square times dx. Towards dx, x term suit, toward dv, v term suits. Exchange them mathematically. V square is in division from right to left, and x is also in division from left to right. We have dv over v square, and we have dx over x. Look at this, integrating with respect to their independent variable. Here on the left with respect to v, on the right with respect to x. It is case of ln because we are familiar. Differentiation of ln x is 1 over x. From this power is not 1. If power of v is 1, it would have been ln v, but it is not the case. Add 1 after after dragging the function towards numerator. It is r ln x. Now add 1. Whatever the function is, we convert this one into numerator. Except when it has power 1, it is case of ln. When it has power 1, it is case of ln. Adding 1 into the power, we have v raised minus 1 divided by the same is equal to ln x plus c. Okay, cool. Converting this exponential towards something positive, it can be written as minus 1 over v is equal to ln x plus c. Minus 1, v means, we have assumed that where it is, y is equal to vx. V means y over x. V means y over, and this is y over x is equal to ln x plus c. Owing to double division, x will be in the numerator. We have minus x over y is equal to ln x plus c. Leave here or right or shift xy on the right hand side. It's cool. That is the solution of question number 7, differential equation. Tiny differential equation. If they have little bit more power, then they are going to be very complicated, especially when to integrate them. Here these are simple cases, just adding one Rn institution, nothing more than that. Question number 8. Question number 8, we have dy over dx, y over x plus root x times y, in root x times y. Let's see how to deal this. Question number 8, it reads as dy over dx, y over x plus product of xy in the root. Homogeneous equation. Just switch over to two suppositions y is equal to vx. After differentiating with respect to x, we are going to have as dy upon dx is equal to v plus x times dv over dx. Substitute both these values here. Instead of dy upon dx, we have v plus x times dv over dx. Instead of y, vx, x is in x plus root x, y means vx. Here, pair of x, or there is x square, it is a perfect square. Drag it outside of the square root, v plus x times dv over dx. We have vx over x plus pair of x, root v. X square means x outside. Taking x common from denominator and cancelling out, we are going to have something v over 1 plus root v, v plus x dv over dx is equal to v over 1 plus root v. Shift v from right to left, changing its symbol. X dv over dx is equal to v over 1 plus root v minus v. Taking LCM, 1 plus root v, v minus v times the bracket 1 plus root v. We have x on the left hand side, x times dv over dx. Here it will become v minus plus minus 1 and 1 upon 2, powers are same, they are multiplication, add their powers. V times root v is v raised 3 over 2, 1 plus v. Cancelling out, we have negative v raised 3 over 2 divided by 1 plus root v. Now we are ready to rumble. It's separable differential equation. Shift dxx to the right and both of these terms towards dv. It will become something 1 plus root v divided by v raised 3 over 2 dv. Towards dv, v terms roots, and we need neither dv and dx in denominator. So it will become minus is already there, minus dx over x. Integrating with respect to their independent variables, dividing separately, we have 1 divided by v raised 3 over 2 under root v divided by v raised 3 over 2 dv. It is a situation of simple ln x. Okay. We shift this v raised 3 over 2 to numerator, changing the symbol of the power. There is 1 over 2, there is 3 over 2. 1 minus 1 over 2, it will become v raised minus 1, v raised minus 1. 1 upon 2 minus 3 over 2, 2 LCM 1 minus 3, it will become minus 2 over 2 minus 1. Okay, cool. We have something like v raised minus 3 over 2 dv plus, here remains v raised minus 1 dv, and it is the situation of minus ln x plus c. ln x plus c. We are cool. Let me make some space, some room to complete this question. Okay. Add 1 into my negative 3 over 2, it will become negative 1 over 2. It is again the situation of famous ln. How? Let's see and find out. Let me write this step again for your convenience. V raised negative 3 over 2 dv, and this one v raised minus 1 dv, and we have already done this minus ln x plus c. Add 1 into the power, it will become minus 1 upon 2 over minus 1 upon 2. Adding 1 into the power, it can be written as 1 over v dv. We cannot add 1 into negative 1. We cannot add 1 into negative 1 in integration. It is case of simple ln. Function derivative situation. Minus ln x plus c. We are cool. Divide another divide owing to double upon 2 converted in denominator and turning this exponent to positive, writing in denominator. 1 upon 2 means root, square root. It is our ln v minus ln x plus c. They put what we have assumed at the beginning, y is equal to vx. From this obtaining the value of v, that is y over x. Plug in here the value of v, that is y over x, plus ln v means y over x. Shift ln x here, it will become positive ln x is equal to c. Owing to double upon, it can be written as 2 times root x over y. X is in the numerator. X is in the numerator. Here, applying the tiny property of log, they are in addition. They can be merged as a single term in multiplication. Y over x times x is equal to c. Cancelled out. We are left with minus 2 times root x over y plus ln y is equal to c. That's our answer in that case. That's our answer in that case. Moving towards, it's 8. Moving towards question number 9. Moving towards question number 9. Same. It's homogeneous. Path 3, 3, 1 and 2. It's also 3. It is given to us. They are homogeneous. Just solve them. Okay, cool. Question number 9. Question number 9. dy over dx, it is equal to 3x cube plus y cube divided by x times y square. But y is equal to vx, its differentiation with respect to x is v plus x times dv over dx. This is the way to solve homogeneous differential equation having no constant term. V plus x times dv over dx, 3x cube. Instead of y, vx. Having cube, v cube x cube over x, y square means v square x square. Look at this, x has been cancelled out on the right hand side in case of homogeneous equations. Taking x cube common from the numerator, we have 3 plus v cube, if I'm not wrong. Good. X square, it will become x cube times v square. The x cube has been cancelled out. We have v plus x times dv over dx on the left hand side. Whatever remains, just shift v here from positive to negative, from left to right. X times dv over dx. Here we are left with 3 plus v cube over v square. Shifting this v here, it will become negative, taking LCM. V square is LCM. 3 plus v cube same. V square into v, it will become v cube, cancelled out. We are left with something like x times dv over dx. We have 3 over v square. Now it is separable differential equation. We need neither dv in the denominator nor dx. dv already in the numerator. It's good, cool for us. Shift dx towards right, as we have to switch from division to multiplication, from denominator to numerator. X times dv is equal to 3 over v square dx. dx suits all x terms, dv suits all v terms. Do this transition, we have v square times dv or 3 over x times dx. Mathematically, from division to multiplication, from multiplication to division. Integrating with respect to their independent variables, v square dv, 3 outside, it is 1 over x dx. It will become something like v cube over 3, simple integration is equal to 3. It is case of ln x plus c. 1 over 3. We put the value of v, it is going to be y over x, the ratio of y and x. Y over x cube is equal to 3 times ln x plus c. Okay, cool. Shift 3 over there, and let me share with you a good point. 3, it will become 9 ln x plus 3c. You see, there is no 3c, only c. There is no 3c, only c, because multiplication of a constant with a constant, there is another constant. Add constant into constant, we are going to get constant. Divide constant by constant, we are going to divide constant. Divide, multiply, add, subtract constant with constant, we are going to get constant. Most effectively, it is only written C. It is only written C. I have written C1 for your convenience to give you idea about that. From where this 3 has vanished. 3 times a constant, another constant. 3 times a constant is still a constant. 3 times a constant is still a constant. That's our answer in that case. Moving towards question number 10. Lingering along despite all odds, the journey must continue. Never give up, no retreat, no surrender should be your slogan to be chanted in student life to get success. Never give up. Keep on rolling. Little by little, try and try till you die. Question number 10. I'm not a motivational speaker. Just simply solve this. dy over dx is equal x plus 3y plus 3x plus y. We have formula, plug in y is equal to vx, differentiating y with respect to x, applying product rule, we are going to have something like this. V into x, differentiation of x is 1, I have it written. Cool, plug in both these values here. dy over dx means v plus x times dv over dx. X same, 3y means v times x plus 3xy means v times x. Taking x common from the denominator and numerator as well, we are going to have 1 plus 3v. X common from here, it will become 3 plus v. Cancelled out. Shift v on the right hand side. What we are going to get? X times dv over dx. We are left with 1 plus 3v divided by 3 plus v. Shift v here. Taking LCM, 3 plus v is the LCM. 1 plus 3v minus v times 3 plus v. V times 3 plus v. Okay, cool. X dv over dx on the left hand side, we have 1 plus 3v, it will become minus 3v minus v square over 3 plus v. Cancelled out, cancelled out. Now we are ready to roll. It is a separable differential equation. Now separate the variables. 1 minus v square over 3 plus v. Okay, cool. Now we need neither dy in denominator nor dx. dv is already in numerator. Good. Shift dx here. Towards dv suit v terms. It will become mathematically 3 plus v divided by 1 minus v square. And on the right hand side, dx over x. dx over x. It is integrating with respect to independent variables. We have 3 plus v over 1 minus v square times dv is equal to 1 over x times dx. It is simple case of ln. It is simple case of ln. Here, look at this. It's not function derivative situation. Factors are possible, linear and different. Apply partial fraction here. Partial fraction here. Resolve into partial fraction. Resolve into partial fraction. As I am resolving, I am taking this only this portion. Only this portion. Factorize denominator 3 plus v. It will become 1 minus v times 1 plus v. We have dv. Resolving into partial fraction, then plugging in here, and it is integration of 1 over x is ln x plus c. Just solve left hand side. Differential equation, especially the homogeneous, is the exercise of almost all cumbersome techniques of integration. Here comes the partial fraction. I am going to have a over 1 minus v plus b over 1 plus v is equal to a over 1 minus v, b over 1 plus v is equal to 3 plus v times 1 minus v into 1 plus v. Taking LCM, a plus 1v plus b times 1 minus v. Denominator comprises 1 minus v times 1 plus v. It's our 3 plus v divided by 1 minus v, 1 plus v. We are familiar, we are cancelling because I shift this 1 minus v times 1 plus v towards left from division to multiplication, they are cancelled out. Even this one from division to multiplication, they are also cancelled out. I have no space, I have just cancelled them. multiply A throughout, I am going to have A plus AV, B minus BV is equal to 3 plus V. Collecting the like terms, and finding the values of A and B, we have AV minus BV plus A plus B is equal to 3 plus V. Taking V common, we are going to have, A minus B plus A plus B is equal to 3 plus V. Now compare, this one is equal to this one, means coefficient of V is equal to V, means A minus B is equal to 1, and the second one is constant is equal to constant, that is A plus B is equal to 3. Solve 1 and 2 simultaneously. Just simply add, you are going to get the value of A or B. Plug in any other equation, you are going to get the other value, and we are done almost. Here we have A minus B is equal to 1, cool. A plus B is equal to 3, cool. By adding or subtracting, just I am adding. 2A is equal to 4, A is equal to, putting in an equation, A plus B is equal to 3, A is 2, 2 plus B is equal to 3, then B is going to be 1. B is going to be 1. Plug in here the values A over 1 minus B, here and integrate, here and integrate. Something like this I am going to have. A means 2 over dV over 1 minus V, plus B means 1, dV over 1 plus V, and on the other hand side we have already ln x plus c, Now we don't need any of this. Cool. Differentiation of minus V is negative 1. Differentiation of negative V is negative 1. So there is deficiency of negative compensating. Now its function derivative having overall power, I used to write for you 1 in order to emphasize the situation. In the situation of ln, you are not going to add 1 into it, add its function derivative. It's our situation of ln 1 plus v is equal to ln x plus c. Okay, cool. It is function derivative having overall power 1. It is another situation of ln, that is 1 minus v plus ln 1 plus v is equal to ln x plus c. Okay, cool. This coefficient has the capacity to become power owing to the tiny property of logarithm 1 minus v times raised minus 2 plus ln 1 plus v is equal to ln x. Look at this, constant has wonderful capacity, like a spring to be stretched or released. It can be written as ln c1. Constant can be written as ln c1. Now they are merged simply. Ln, turn the exponent positive, I can write 1 divided by 1 minus v whole square is equal to plus ln 1 plus v. It is going to be ln x times c1. From addition to multiplication, they can also be merged or bent. Ln times 1 over 1 minus v square times 1 plus v is equal to ln x times c1. Taking e as a base, ln cancelled out. Re-put the value of v. We are going to get something like 1 minus v has a square means y square over x square. Sorry, it has overall square. If I am not wrong, it has overall square. Okay, cool. 1 plus y over x is equal to x times c1. Okay, taking LCM, it will become x square minus y square. If I write, sorry, only x and y, this is overall square. Okay, cool. Times x plus y divided by x is equal to x times c1. Okay. Distribute this square to numerator as well as denominator. To numerator and denominator as well. Shifting this. Okay, I am writing one step more for you. 1 minus x minus y whole square divided by x square times x plus y divided by x. We are going to have xc1. Okay, I require some more steps to be written down. For them I need space. I am making room for them. Okay. Shift this x square in numerator owing to double upon x square over x minus y whole square times x plus y divided by x is equal to x times c1. This x cancelled out. What remains? X times x plus y divided by x minus y whole square cx1 or xc1. Even I can cancel this one. Your book has left the answer here. Your book has left the answer here. He hasn't. They hasn't cancelled. They haven't cancelled this x. But I am. But I am going to, because it is possible. X plus y divided by x minus y whole square is equal to only constant. That's my answer, RC1. Your book has left the answer here, but it has the capacity x to be cancelled out. That I have done. That I am doing. Okay, cool. Your book has answered this. I have answered this. Whatever suits you, just follow. Now we are going to get bingo. We arrived at question number 11. 11 is a prime number, the final question. Having trigonometric function. Okay, cool. We can deal this. We can deal this. It's simple as well. To solve a differential equation, especially homogeneous, you must have good grip on direct formula for integration, synthetic deviant, partial fraction. All these three techniques, you should have grip on them. Especially they are very cumbersome. The students always avoid such type of questions in synthetic deviant, partial fraction, because they are time consuming and space consuming, as you have just witnessed. Okay, without wasting time, just compile the frame. Y plus x times cot y over x times dx minus x dy is equal to 0. In all the previous 4 questions, we have the ratio dy over dx, the magical ratio dy over dx. Credit goes to Newton. Somebody said that to Leibniz as well. Okay, find the ratio dy over dx. Y plus x times cot y over x times dx. Shift x dy on the right hand side, it will become positive. Shift dx here, x here. Y plus x cot y over x divided by x is equal to dy over dx. Now we are here according to the previous question. We have the ratio of dy over dx. Plug in the values. Y is equal to vx. Derivative of y with respect to x is v plus x times dv over dx. Plug in both values here. Okay, y means vx plus x cot y means there's a ratio of cot. Y means vx over x cancelled out divided by x. dv over dx means v plus x times dv over dx. Look at this. X common and then cancel out x as well. X common, we are left with v plus cot v. Okay, it's going to be simple enough now. Divided by x cancelled out. We have v plus x times dv over dx. We are left with v plus cot v is equal to v plus x times dv over dx. Shift v here. V plus cot v minus v is equal to x times dv over dx. Cancelled out. It's no more. Now it's a separable differential equation. Shift dx and x here. Cot there mathematically. We are going to have something. Dx over x is equal to 1 over cot v in division. From multiplication to division, we have dv divided by cot v. Okay, cool. Integrating with respect to their independent variables 1 over x dx. To integrate this, 1 over cot is equal to 10. 1 over cot is equal to 10v. It's dv. It's famous case of ln. Its integration is also ln sec. To me, your writers left as minus ln cos, but I take ln sec. Integration of 10 is ln sec. ln sec. Both are possible. Both are possible. I follow this ln sec. Mostly your book follow this. Tan x is equal to negative ln cos x. Let me give you another one time more idea. There should be one. Power can be, coefficient can be made power. It will become something like cos raised to minus 1. Converting the power to positive, it will become 1 upon cos. We are famous. Cos is reciprocal of sec. Most situations are identical, equivalent, mathematically equivalent. You should have a fair idea. Where to left, where to not. 1 upon x means ln x. And here it is mine ln sec v plus c. Instead of c, I'm writing ln c because to merge the constant. Constant has the flexibility. Constant time constant, another constant. Constant divided by constant, another constant. Constant raised to any power constant. Taking the ln of constant, it is a constant. So I can write constant here like instead of c ln c. Now ln x, I have ln sec v times c. Taking e as a base cancel out, we have x is equal to sec v times c. We put the value of just v, that is y over x. Y over x is y over x times c. Leave here or shift constant here, it's up to you. Constant makes no difference. Constant makes no difference. If you can shift here, it will become 1 upon cx. We have sec y over x. 1 over c, reciprocal of a constant is still a constant. Reciprocal of a constant is still a constant. You can write c1x times sec y over x. It's our answer in that case. It's our answer in that case. We have just compiled only 5 questions based on homogeneous differential equation. We have to utilize this assumption in case of simple homogeneous differential equation. Remaining questions are coming for you along with some initial conditions. Initial conditions are for the determination of this C. It's all by itself next.